Okay, so let's talk through section 1.2. Just a couple vocab words to start us out here. The first one is a line segment. And a line segment, pretty much as the name is it's just a portion of a line. All right, so we're going to go ahead and say portion of line. And a typical picture is you would have an initial starting point like point A, continue in a straight line to an ending point, point B. Now, when we write this using notation, we just do AB very much like we would for a line. But instead of putting the line above it, we're going to put a segment above it. And that is a line segment. Betweenness, that simply means that a point is located on a line, but between two given points. All right, so the point is between, which is really the name, two given points. So if I give you a picture here of A and B, all right, betweenness really means if I have a point C between A and B, it's on that same line. All right, so the 3 points are collinear, and that point is between. Now, symbols is a little bit harder here. So what we typically do for this is we say that the measure of AC, all right, notice I don't have a marking above it, that indicates the length, plus the measure of CB, all right, equals the total length of that for AB. So AC plus CB equals AB. That means that C meets the definition of betweenness, all right, which is collinear. And C is between A and B. All right. Now, congruent segments are simply segments that are the same length. So if I have segment AB here, and I have segment CD, all right, as long as those have the same length, because they're segments, then they're congruent. All right, so it's two segments with same length. Now, the thing that you have to keep in mind is later when we have objects, congruence is really shape and size. It's just segments only have one shape that they have. So symbols to say this, if I want to say segment AB is congruent, it's like an equal sign with a little squiggle above it for congruence. All right, CD. So AB is congruent to CD, which for line segments, that really just means the length of AB equals the length of CD. And notice when it's length, we don't put the marking on top, but when it's the actual object itself, we do. Now, where these get used tend to be in problems revolving around betweenness and segment addition. So if I go ahead on this first one, it says find AC. All right, so we're assuming that B is between A and C. So the sum of those two pieces, if I take AB plus BC, that's going to equal AC. So that's 1 plus 2.5 equals AC, or AC equals 3.5 units. All right, if I go to the second one here, it says find AB, so this little segment, and they tell us that AC, the full length, is 12.3 centimeters. All right, so I have the short segment AB plus the longer piece BC equals the total. All right, so that's really AB plus 5.8 equals 12.3. And if I subtract that 5.8 from both sides, all right, that's going to take me down to the length of AB. All right, so 12 minus 5 is 7, and then we're going to go a little bit below that, so 6.5, I believe, and double check my math on that. Units on this one were centimeters, units on the last one were centimeters as well. All right, now a lot of times I shift into algebraic problems on these. So in 3, you'll notice that we've got a little similar setup. We're going to take AB plus BC equals the total length AC. So in this case, that's A plus 3 plus 5.7 equals 3A plus 5. All right, so if I clean this up a little bit, I've got A plus 8.7 equals 3A plus 5. If I subtract A from both sides, I have 8.7 equals 2A plus 5. If I subtract 5, I've got 3.7 equals 2A. All right, and then I'm going to divide both sides by 2, so 3.7 over 2 equals A, which is really 37 over 20, which doesn't reduce, and that would be my fraction answer for that one. Now, we could go to a decimal if we wanted to. All right, but these are typically the type of questions that you're going to see with betweenness and angle addition. All right, now if I go to, occasionally they'll just do it all in words here. They'll say determine if B is between A and C. So they're saying find out, does B meet the definition of betweenness for A and C? So if I set this picture up, that would mean AB, so the 4, plus BC, the 8, all right, would need to equal that other piece, which is 11. All right, so if I add 4 and 8 together, I get 12, which is not equal to 11. All right, so we could say B is not between A and C. All right, now the last few problems here deal with congruence. So it says, are they congruent, which basically means do they have the same length. So it says AB and BC. So AB is 2 feet long, BC is 3 feet long. So that would be false. They are not congruent. If I go to B, I've got CD is congruent to BC. So CD is the bottom here, which is 3. BC is the right, which is 3. So that is true. And if I go to C, I've got AD is congruent to BC. So AD is 3 feet, BC is 3 feet, so that is also true.